Isoparametric material. A truss element has some mechanical and physical properties in all directions. That is, they are independent of directions. For instance, cutting out three tensile test specimen, one in x direction, one in y direction, and other in 45-degree in the xy plane. A tension test on each specimen will result in the same mechanical values for the modulus of elasticity, yield strength, and ultimate strength. Most metals are considered isotropic. In contrast, fibrous materials such as wood typically have properties that are directionally independent and are generally considered anisotropic. Not isotropic. Constant static load. The loads that are supplied to the stress element are assumed to be static and not to vary over time period which is being considered. The assumption is only valid if the rate of change of the force is much less than the applied force. The loads applied slowly if the loads are very significantly. If the variation in load is not much less than the applied force, then the problem must be considered as dynamic. Poisson's effect not considered. Poisson ratio is a numeric material parameter. Poisson's effect is when uniform cross-section bore is subjected to a tensile load and the axial stretching is accompanied by contraction in the lateral dimensions. For dimensional truss element, this defect is neglected for simplicity, that is v is equal to 0. Cross section remains plane. For one dimensional element, although the force are acting on only the centroid of the truss, that is bore element, it is assumed that it has a uniform effect to the plane. Then thus the cross section remains plane. For one dimensional element, although the forces are acting on only the centroid of the truss or bore element, it is assumed that it has a uniform effect to the plane. Thus the cross section will move uniformly and remain plane, normal to the axial before and after the loading. Homogeneous material. Homogeneous material means it have uniform properties, uniform characteristics throughout the length of the structure. That is the homogeneous material. Homogeneous means so throughout the material it have uniform characteristics, uniform properties, that is called homogeneous. A truss element has the same material composition throughout and therefore some mechanical properties at every position in a material. Therefore, the modulus of velocity E is constant throughout the truss element. A member in which material properties varies from one point to another point in extent the member is called inhomogeneous, not homogeneous. If a truss is composed of different types of material, then it must be divided up into elements that are each of this single homogeneous material, otherwise the solutions will not be exact. The left figure shows composite bar composed of brass and aluminium. This structure can be divided into two channels. Okay, two channels. So the difference between truss and the frame. Truss only concentrated loads act. Concentrated loads, uniformly distributed loads, moments, all can act. Loads active only at the joint. Loads can be applied the joints Then truss members undergo only axial deformation along the length of the member. Frame members can undergo axial and bending deformation. Translations as well as notations. A grid is a structure on which loads applied perpendicular to the plane of the structure as opposed to plane frame, where loads are supplied. Grid is a structure on which loads applied perpendicular to the plane of the structure and opposed to the plane frame. When loads are applied in the plane of the structure, stiffness matrix is a finite element equation for truss element. There are two joints for arbitrary inclined single truss element at an angle positive counterclockwise positive x-axis. For each joint there are 2 degrees of freedom. A joint can have horizontal displacement and vertical displacements. Hence, for each joint there are 2 degrees of freedom, that is joint can have horizontal displacement and vertical displacement. Hence for single truss element there are 4 degrees of freedom. Nodal displacement degrees of freedom at the node force freedom as shown. Note that deformation occurring in the truss members are so small and they are only axial. The axial displacement of the truss can be resolved along horizontal y-axis and vertical y-axis. But in our derivations, let us solve horizontal and vertical displacements of a joint along perpendicular to the truss members refers to sign component acting towards negative y dash direction, all other components acting positive x and y directions.